Hi everyone, welcome to the 21st edition of Group Exhibit, Hydrogen Fuel Cells and Batteries. I invite you to come and have a seat. Drinks is on the house. Just raise your hand and the lady can come and serve you a drink. We'll be discussing with AVL Fuel Cell product portfolio today. Please help me welcome the Manager of Fuel Cell, Mr. Jürgen Rechberger.
Hi.
Thank you for your time.
You're welcome.
For those that are not familiar with AVL List, could you start us off with just a general overview of the company?
Yes, of course, you're welcome. So AVL is a Graz-based Austrian company. We are basically coming from the automotive industry. We are the world's largest independent engineering supplier within the automotive industry. That means we develop, our main business is development of powertrains for the automotive industry. So that means we develop, for example, conventional powertrains with classical combustion engines. We develop hybrid powertrains, battery powertrains, and also one of the new topics in our company is fuel cell powertrains. So that's the one hand side of our company, that's the engineering. On the other hand side, we have a very large division for test systems. That means all kinds of test equipment which is necessary to develop automotive powertrains. That means engine testing, battery testing, vehicle testing, fuel cell testing, all that stuff is also supplied by AVL.
So I think it's important to mention that AVL does not manufacture the products.
Yes.
You offer engineering services, and then your clients then, if they were to develop a product with you, how would it go about reselling that final design product?
So that's important to understand. That is different for AVL than a lot of other companies here in this exhibition. We are not necessarily interested in selling hardware products. We are supporting companies in the development of competitive fuel cell products. That means that might start from small, very small scope of work projects of a few thousand euros up to multi-million-dollar contracts where we develop a product from the scratch till start of production. So that's very different, but we are generally not interested in selling hardware. And typically how a business then is set up, it's typically an engineering contract. So we get awarded with an engineering contract with clearly defined milestones and objectives. Or the other hand side is if we have developed already a product based on our internal R&D, like we did in our SOFC program, we can sell this complete technology, this complete product based on a royalty license agreement to a sales and manufacturing partner.
So then, like you said, AVL has a broader scheme and is in the powertrain industry and things like that. But let's focus on fuel cell, hydrogen, and batteries. There's two main programs that you have. You have a PEM-FC program and an SOFC. Let's start off with the PEM-FC program that you have. Can you give us some one of the main things you bring to the table there, the focus of this program?
Yeah. So basically, as AVL, we definitely believe in the future of fuel cell vehicles. We don't expect that fuel cells really will more or less completely replace combustion engines, but we think we will have in the mid to long-term future a portfolio of different powertrain technologies and a portfolio of different fuels. And this is also where we're absolutely convinced that fuel cell propulsion systems will play an important role. And that's the reason why AVL has decided already 10 years ago to invest significant amounts of R&D into fuel cell propulsion systems. And today, in our PEM program, we are basically supporting the complete automotive industry in the development of fuel cell vehicles. And for example, we had performed with more than 7 automotive OEMs projects on the engineering level of automotive fuel cell systems. That the scope also here is very different from packaging, from typical engineering stuff, to very specific fuel cells related things, like for example with our diagnosis system. So based on our history, we have developed a low-cost fuel cell diagnosis system which can detect real-time in a vehicle the critical failure states of a fuel cell. And we have applied this methodology already into the fuel cell vehicle programs of 7 major automotive OEMs.
And this methodology is referred to as THDA. THDA for total harmonic distortion analysis, and it's a software-based product.
Yes. So basically, the big advantage of this technology that if you apply it to a fuel cell vehicle, it doesn't add any additional hardware costs to the vehicle because it's basically only software. So what we do is we superimpose a very well-defined signal to the current of the fuel cell, and in the vehicle, this can be done by the power electronics. So we don't need any hardware for this. And the rest of it is basically only an algorithm which can be placed in the fuel cell system control unit.
So the main advantage of this then, because there's no hardware associated with it, would be the low cost?
Absolutely. It's more or less, it doesn't add any hardware cost to a fuel cell vehicle.
And therefore ready for any interested party?
Of course, yes. It's not only for fuel cell vehicles. Basically, it can be applied to any PEM product. And we have tested it already with Japanese NFARM products. We have tested it for 20 different stack platforms. So it works basically with any kind of PEM fuel cell system.
And you have that same analysis software available in a lab unit.
Yes, exactly. So we sell this product on 2 different paths. One is for complete integration into fuel cell systems. And the other approach is just a plug-and-play laboratory instrumentation system. So it's a blue box. You can see it on our booth. We start selling it now, more or less. And you just buy this box, bring it to your fuel cell test station, connect it to the stack, and you can start testing it. And the device will tell you all critical failure modes of the fuel cell. And it doesn't only tell you that there is a critical failure state, it tells you also why. So we can differ the different failure modes, for example, membrane drying, air starvation, hydrogen starvation, and liquid water issues.
And just to give you an idea, their booth is located as E55, which is right behind us. And I also want to remind you that this is a public forum, so you're more than welcome to ask questions. Just raise your hand and we'll bring a microphone down to you. But in the meantime, I would like to go back to, in your PEM fuel cell program, you also have AVL Fire. Can you tell us what this is all about?
So AVL Fire is a commercial software simulation platform. We can simulate PEM cells up to big stacks. It's a multi-physics CFD code, already developed 20 or 30 years ago for different applications, but it's now available also for PEM fuel cells and also for SFC, actually. And it's a very flexible multi-physics code, and special focus we put on is the two-phase flow. So with this tool, you can really in-depth analyze where in your flow field, in a gas diffusion layer or whatever, you will form liquid water. So you can use this tool very efficiently to optimize the water management of the PEM fuel cell.
So before we jump into the SOFC world, I'd like to just maybe put a little point about AVL is developing an FC car, is that correct?
Yes, that's correct. We have started, or more or less decided this in the end of last year, that we will build up our own fuel cell demonstration vehicle. We are doing the first steps now here. We develop our own PEM system, and probably in next year's Hanover Fair I can tell a little bit more about this.
So we'll have to be patient and wait for next year. But in the meantime, let's dig into the SOFC program. Obviously, SOFC are usually to support larger application in the 1 kilowatt to megawatt range. Stationary is usually the thing. Right at your booth, you have on display one of your actual product. Can you tell us about it?
Yes, here in Hanover we have 2 products from our SFC program. On the one hand side, we have here on the show a 10 kilowatt stationary power generator. So it's a typical fuel cell product for decentral power generation. So it converts more or less in natural gas with an electrical efficiency of around 60% into electricity. So it's a very efficient stationary power generator. It's a modular design. We have done based on these platforms already projects with customers from 5 kilowatt to 20 kilowatt. So it's very the design is very modular, and I think the big advantages are obvious. It's highly efficient, it's low noise, zero emission. So I think the SOFC has a very big future in the stationary decentral power generation.
Where would be the main application for such a decentralized power unit? Can you give us examples?
Yes, it depends obviously on the installed power. Based on this platform, we do at the moment projects with international customers from the 1 kilowatt micro CHP up to the megawatt range. So you can apply this technology into different markets. But for our internal 10 kilowatt platform, it's small businesses, shops, small workshops, or things like that.
You mentioned efficiency of the unit. For those that are not maybe familiar with what a standard natural gas engine would be, what efficiency in terms of scale, can you quantify the differences in terms of efficiency between natural gas engine and your product?
I think for a 10 kilowatt natural gas combined heat and power unit, we are talking about of 30% electrical efficiency compared to 60.
So there's a main advantage there just on the efficiency, but there's other advantages to go to such a product as the 10 kilowatt decentralized units you have. Can you give us more advantages?
I think the big advantage from AVL strategy point of view is that we don't need to develop a new market for this stuff. So there is an existing market. They sell a significant amount of gas engines in that power level from 5 to 20 kilowatt per year. So we just need to replace a bad product with a better product. Obviously, it will take some time that we can fully control the cost because it's an expensive technology at the moment because we are not in volumes. But basically, the market is there. We just need to address it with a very good product.
And some advantages over just the efficiency, there would be the low noise.
Absolutely, yeah.
And also the low emission, which is really important. That's the whole point behind fuel cell and hydrogen. But like you said, it's not a new market. It's existing. The need is there. What do we need then to get the return on investment or the cost of this product down? Just pure volume?
I think it's mainly volume, yeah. We need to bring SOFC cells and stacks into volumes. The rest, I think, the rest from the system, the complete balance of plant, we know what we need to do to reach the target cost, but it's mainly bringing really cells and stacks into volumes.
Okay, so for those that are interested, I invite you again to their booth, which is located at E55 right behind us. And then in the SOFC program, you also have another unit on display at your booth, which is your APU. Can you tell us what it stands for?
Yes, APU stands for Auxiliary Power Unit. It's basically a portable solid oxide fuel cell power generator, which converts any kind of conventional fuel. At the moment, we use conventional diesel into electric power. It's at the moment a platform in the range of 3 to 5 kilowatt. And the basic motivation was to develop this was the US heavy-duty truck industry in the United States. Because they typically idle their engines for 8 hours a day. That means that the driver in the United States lives in the truck and he needs electricity for cooking, for television, for cooling, for all this kind of stuff. And how they do it is they leave the main engine running, which is obviously not very efficient. So, and this was the motivation for us to develop such a product, to bring it in as an onboard power generator for heavy-duty trucks. And the interest of the truck industry is quite big, but obviously the truck industry is a very cost-driven industry. So we need to come down to reasonable cost. And due to this, we are focusing at the moment on special purpose vehicles, for some niche markets where the price or cost target is much higher. And there are a few markets where we really can enter with the cost we have today, go into a small-scale manufacturing and bring these products into the field. And that's exactly where we are working on at the moment.
So this APU unit, like you said, runs on diesel. Yes. So it's not quite as efficient as your natural gas auxiliary other unit that you have, your 10 kilowatt SOFC power generation, but it's still over the general idling of a heavy-duty truck. Absolutely. More efficient.
Yes.
And like you said, you're trying to put it in niche market like yacht and leisure camping, exactly. Things like that. It is a product ready for resale?
I would say we are about 1 to 2 years away from it. Also, with this product, AVL will not necessarily manufacture it. As I have explained in the beginning, we are not a manufacturing company, we have an engineering company, so we are not necessarily manufacturing it. But there is a little bit side effect to this, that we actually will manufacture it for these niche markets. So there has been the decision by AVL that we will manufacture and sell these products for this special purpose vehicle niche market. But we will not manufacture it for high volumes for the US truck industry, and therefore we are at the moment already negotiating agreements with sales and manufacturing partner in the US heavy-duty truck industry.
So there is legislation or regulation in place for the large trucks to bring their emission down. That legislation doesn't exist for small purpose vehicle. Would such legislation be advantageous to AVL or?
Of course, yes. In any kind of, I think in most of the applications, legislation can help in the implementation of fuel cell technology into the market, because it will create not only incentive, it will create really a need to implement these technologies. But especially for these special purpose vehicles, it will be very difficult to apply this. But obviously for a lot of other markets, CO2 reduction needs will help to simulate the market.
Well, Mr. Rechberger, I'm really pleased to have you with us today.
You're
Please
welcome.
help me thank him for his time.
You're welcome. Thank you.
Thank you very much. And I invite you to stay tuned. We have more coming up right after this. Right after us is hydrogen as part of the renewable energy economy. Dr. Christopher Hebling, the division director at Fraunhofer, will be talking right after. Please stay tuned. Thank you for your time.